Hi, this is Fazana again. Welcome to part 2 of this topic. I hope you've watched part 1, where we did some easier questions and we're just rising up a level now. In this video, we will continue to learn the connection between lengths, areas, and volumes of similar shapes and how to calculate the areas and volume. Let's begin. Hope you like the similar balloons there. Okay, the volume of two mathematically similar solids are in the ratio 27 to 125. So that is the scale factor or ratio of the volume. So we'll just write it as a ratio form, 27 to 125. Yeah. The surface area of the smaller solid is 36. Work out the surface area of the largest solid. So you can tell we've got to find the ratio or the scale factor of the length first. So we know we're going to cube root these numbers because the scale factor of the volume is the cube of the scale factor of the length. So the cube root of 27 is 3. And the cube root of 125 is 5. Yeah? So you can tell the scale factor of your area will be your scale factor of your length squared. So it will be 9 and 25. Okay? Now, if they're saying the surface area of the smaller solid is 36, you can tell you've multiplied it by 4. So then all you've got to do is multiply that by 4. And you get 25 times 4 is 100. Yeah? So the surface area of the larger solid is 100 centimeter squared. Okay? Alright. As I say, once you get that also, the scale factors all sorted, then your workings just come out pretty effortlessly. Okay, two mathematically similar frustrums have heights of 20 and 30. So again, you can tell the scale factor of your length is 20 to 30, and we'll just calculate it as normal here. So 30 divided by 20 equals 1.5. Okay, the surface area of the smaller frustrum is 450 centimeters squared. So you know the scale factor of your area will be 1.5 squared. So when you're taking the surface area of the larger frustrum, you're going 450 times the scale factor of the area, which is 1.52 squared, which will give you 1012.5. Yeah? So 1012.5 centimeters squared. All right, yeah? Okay, next. X and Y are two geometrically similar solid shapes. The total surface area of shape X is 450 centimeters squared, whereas shape Y is 800 centimeters squared. So again, let's go scale factor of the area is 800 divided by 450. And this must be a calculator question because I've just got 1.7 square recurring. Yeah. Okay, so your scale factor of your length will be the square root of the 1.7 recurring, which works out to be 1.3 recurring. All right. Okay, the volume of shape X, which is the smaller shape, is 1,350. So we know we've got to find the scale factor of the volume, which will be 1.3 recurring cubed. Yeah, I'll just put that in brackets. Okay, once you calculate that, or you don't really have to calculate it, you just go 1,350 times 1.3 recurring cubed, and you get 3,200 centimeter cubed. Alright, yeah, cool. Okay, this question's a little different. So again, when I said that sometimes you get so used to answering the same sort of questions that when you look at another question, you just assume it's the same thing. So in this case, it's a bit of a reverse situation. Okay, Mrs. Hampton is potting plants. She's using two mathematically similar pots. The smaller is 10 centimeters tall and the larger one's 14. So the first thing I do is just find my scale factor of the length, which is 14 divided by 10, which is 1.4. Okay, so I just know I'm one step ahead. She has 2 bags of soil, each containing 30 liters of soil. Okay, so you've got 30 liters there and 30 liters there. Okay, with the first bag, Mrs. Hampton fills 20 small pots. Yeah, so she's able to fill 20 pots with the 30 liters of soil. And you can tell this 30 liters would be the volume of soil. Okay, so if she's filling 20 pots, then if she's got 30 liters in the second bag, then you can tell that she'll be able to actually fill less than 20 pots. Yeah, because it's a bigger pot. Okay, so let's find the scale factor of the volume. So the scale factor of the volume would be 1.4 cubed. In this case, can you see we're actually doing 20? Now, instead of multiplying by 1.4 cubed, we're actually dividing it by 1.4 cubed. Yeah? And you get 7.29. So, of course, you've got to round down. So she'll be able to fill 7 of these pots with the 30 liters of soil. Okay, so can you see this is a bit of a reverse situation? Yeah, all right, because the volume in each bag is constant. All right, okay. Next question. 2 clay models of the Statue of Liberty are mathematically similar. Smaller model has a height of 15, whereas the larger one has a height of 20. So you can already calculate the scale factor of the length, which is 20 divided by 15, which is 4/3. Yeah? Okay? And if it's a calculator thing, then we just go 1.3 recurring. Okay? The smaller model weighs 108 grams. So again here, can you tell that's actually the volume? Okay, so we need to find the scale factor of the volume, which would be 1.3 recurring cubed. It's like deja vu, we've seen that one before. Okay, so then you just go 108, because we're finding the larger one. So we're going from smaller to larger, so 108 times 1.3 recurring cubed, and you get 256 grams. All right, yeah, good. Okay, last question. Duncan bought a toy that grows when placed in water. Oh, I had one of those, the aliens. Okay, so this teddy bear grows 10 times larger. Before placing the toy in water, it was 4 centimeters tall, and after placing it in water, it became 10 centimeters tall. So again, we could always do the scale factor of the length first, which is 10 divided by 4, which is 2.5. Okay, and if it grows 10 times larger, you can tell because it's a 3D toy here, Again, we're talking about volume. Yeah? So the scale factor of the volume will be 2.5 cubed, which is 15.625. So when they ask, is the claim reasonable to say it grows 10 times larger? It is in some ways, but it isn't in some. But I think what you need to write is yes, because it grows to more than 10 times larger, because 15.625 times larger is greater than 10 times larger. Yeah, okay. But really, the claim should have been 15 times larger. Yeah, all right. Okay. That's all for now. I hope that was helpful. And again, keep practicing the questions until it just clicks, because when you get them in exams, they could be so similar, and it'll just have a smile on your face. Please join me in part 3 for those higher level questions. Keep working hard. If you have been working hard, then I'm so proud of you. If you've already watched a lot of my videos, then I just know you're determined. Remember, you're in control. Take care. Until next time. Bye.